Page 48.
3. Perfect competition. Module 3.1 Perfect competition. Rationale. Perfect competition is a market structure that determines the prices of various goods in the market. Have you wondered how the prices of wheat are decided by the seller? It provides a benchmark for comparing other market forms. Key concepts: perfect competition, total revenue, average revenue, marginal revenue.
3.1.1 Market. A firm does not just produce, but also sells its output for payment and gets revenue. To sell its product, a firm has to interact with buyers and other sellers of its product. Such an interaction between buyers and sellers is known as a market for the output of the firm. Two kinds of market structure are particularly important in economics.
1.
Perfectly competitive market.
2.
Monopoly market.
3.1.2 Perfectly competitive market. It is a market in which there are a large number of buyers and sellers. No single buyer or seller can influence the price of the product that she or he buys and sells respectively. Therefore, a firm is a price taker and not a price setter. The price that a perfectly competitive market takes is determined by the market forces of demand and supply. All firms produce an identical, that is, homogeneous or undifferentiated product, and all the sellers and buyers have perfect information about the prevailing prices in the market. If a seller charges a price higher than what is charged by other sellers, she will not be able to sell her product, as the buyer will buy the same product from another seller who will be selling at a lower price. There is free entry and exit of firms in this market.
3.1.3 Revenue. Total revenue earned by a firm from selling some output is calculated as total amount small q of output sold multiplied by the market price small p per unit of output. It is denoted by TR and is measured in the unit of rupees. TR is equal to small p multiplied by small q. Since small p is not perceived to be dependent on small q by a firm, therefore small p becomes a constant. This makes TR is equal to small p multiplied by q, a function only of output within bracket small q. If we plot the graph of TR function by placing quantity on the x-axis and total revenue on the y-axis, then we get the TR curve. Let us assume that the market price per unit of output is small p is equal to 10. The total revenue function is tabulated in table 3.1 that follows.
Page 49.
Table 3.1 Total, average and marginal revenue of a perfectly competitive firm. Here we have a table with 6 rows and 5 columns. The first column represents quantity of output sold, or small q. The second column represents price, or small p, charged in rupees per unit of output. The third column represents total revenue in rupees, or small p multiplied by small q. The fourth column represents average revenue in rupees per unit of output. The fifth column represents marginal revenue in rupees per unit of output. From the first row, we understand that when the quantity of output sold is 0, the price is rupees 10. The total revenue in this case is 0. The average revenue is not defined, and marginal revenue is also not defined. When the quantity of output sold is 1, Then the price charged remains the same, that is 10. The total revenue is 10. Average revenue is 10. Marginal revenue is 10. When the quantity sold is 2 and price charged is 10, then total revenue is 20, average revenue is 10, marginal revenue is 10. When quantity sold is 3, then price charged is 10, total revenue is 30, average revenue is 10, and marginal revenue is 10. When quantity sold is 4 and price charged is 10, then total revenue is 40, average revenue is 10, and marginal revenue is 10. When quantity sold is 5 and price charged is 10, then total revenue is 50, average revenue is 10, and marginal revenue is 10. When price is constant at rupees 10 per unit for all levels of output sold, then TR for any output is calculated in column 3 of table 3.1. For example, total revenue at small q is equal to 2 is given by rupees 20. That is, 10 multiplied by 2 is equal to 20. In figure 3.1, we plot the graph of this linear total revenue function, which is given by TR is equal to 10Q. It is a positively sloped straight line passing through the origin because a firm will earn zero revenue if it does not sell anything.
Figure 3.1 Total Revenue Curve. We have before us a graph where the x-axis represents output and there are 5 points equidistantly marked on it. Y-axis represents revenue in rupees and the values are from 0 to 50 with the interval 10. There is an upward sloping line and on it are plotted point A, which is 1, 10, point B, which is 2, 20, point C, which is 3, 30. This line represents the equation TR is equal to 10Q. Please note that it also indicates delta TR and delta Q values. The slope of the line TR equals 10Q is equal to rupees 10 per unit. You may check this by finding the slope using the formula delta TR divided by delta Q. As we move along the line, say from point A, which is 1, 10, to point B, which is 2, 20. It means that if the firm sells another unit of output, then it earns rupees 10 of extra revenue. Average revenue from a given level of output is the total revenue earned from selling that output divided by its quantity. Average revenue is denoted by AR and is measured in unit of rupees per unit of output. The equation is AR equals TR divided by small q, which equals small p into small q divided by small q, which equals small p. AR is not defined for small q equals 0. AR at any positive level of output is therefore equal to the price at which all the units of that level of output are sold. AR at different levels of output is given in column 4 of table 3.1, which has the same entries as in column 2.
Page 50.
Since the price per unit is constant at rupees 10 at all the levels of output, AR is also constant at 10. On plotting the AR curve as a function of output, as in figure 3.2, we get a horizontal line graph.
Figure 3.2 Average Revenue Curve. Here we have a graph with two axes. The x-axis represents output and has been divided into 5 equal parts. The y-axis represents revenue in rupees. It has been divided into 4 parts which are at an interval of 5. There is a line here which represents AR is equal to 10 is equal to price. This line is parallel to the x-axis. If a firm increases its sales by 1 unit of output, then the total revenue earned also increases. The last unit sold is known as the marginal unit, and the change in total revenue caused by the sale of this marginal unit is called the marginal revenue earned by this unit. It is denoted by MR and is measured in rupees per unit of output. The marginal revenue of say nth unit of output is calculated as MR subscript small n is equal to TR subscript small n minus TR subscript n minus 1, where TR subscript small n and TR subscript n minus 1 is the total revenue earned by selling n and n minus 1 units of output respectively. If it is possible to change the output in amounts of less than 1 unit, then marginal revenue of any level of output is calculated as delta TR divided by delta small q, where delta TR is the rate of change in total revenue caused by the change in output sold, that is delta small q. For a linear TR curve, the two formulas give the same value of MR. In column 5 of table 3.1, the values of MR are calculated at different levels of output, and in figure 3.3, the MR curve as a function of the output is plotted to give a horizontal line graph.
Figure 3.3 Marginal Revenue Curve. We have before us a graph with two axes. On the x-axis is plotted output from values 0 to 5 at equidistant intervals. On the y-axis we have revenue in rupees from 0 to 20 with an interval of 5. There is a horizontal line which is parallel to the x-axis, which represents MR equals 10.
Page 51.
Graphically, MR at any level of output is equal to the slope of the TR curve at that point. Since our TR curve in figure 3.1 is a straight line through origin and its slope remains constant at rupees 10 per unit, therefore the value of MR remains constant at all the output levels. Note that both AR and MR are equal to 10 for all the output levels. Therefore, when drawn together as in figure 3.4, the AR and MR curves coincide. This line is also known as the price line of a firm.
Figure 3.4 Average and Marginal Revenue Curves. Here we have a graph with two axes. The x-axis represents output. The y-axis represents revenue in rupees. The x-axis has been divided into 5 equal parts. The y-axis has been divided into 4 parts which are at an interval of 5. There is a line here which represents AR is equal to MR is equal to 10. This line is parallel to the x-axis.